Good morning, class. Welcome to Teach channel. This is your teacher bringing you this lesson to the comfort of your home. For today's lesson, enthalpy of reaction. Let us recall first the first law of thermodynamics. Thermodynamics is the study of heat, energy, and other types of energy, such as work and the various ways energy is transferred within chemical systems. Thermo refers to heat, while dynamics refers to motion. The first law of thermodynamics deals with the total amount of energy in the universe. The law states that this total amount of energy is constant. Here are examples of thermodynamics in our daily activities, like for example, sweating in a crowded room, taking a bath, and flipping a light switch. So, enthalpy of chemical reactions. We define enthalpy as the thermodynamic quantity equivalent to the total heat content of a system denoted by H. The enthalpy change also, which is delta H, is defined as the enthalpy change or defined as the heat of a process when pressure is held constant. That is, delta H is equal to Q at constant pressure, where Q is equal to mc delta T, where m is the mass, c delta T is the specific temperature change. When a chemical reaction occurs, there is a characteristic change in enthalpy. The enthalpy change for a reaction is typically written after a balanced chemical equation and on the same line. So how do we write chemical equations for enthalpy of chemical reactions? For example, when 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water, the characteristic enthalpy change is 570 kilojoule. We write the equation as 2H2 gas plus O2 gas, that is equal to the product of 2H2O, which is a liquid, and you write the delta H here, which is equal to negative 570 kilojoule. So why is it we write the negative? Later on, you will know why we write negative in this equation. Let's move forward. Another example. Write the thermochemical equation for the reaction of PCl3, which is a gas, with Cl2 to make the PCl5 gas, which has an enthalpy change of negative 88 kilojoule. So how do we write the equation? How do we write this equation? We write this as PCl3G or gas plus Cl2 gas yield PCl5, which is also gas. Then write the delta H, which is equal to negative 88 kilojoule. So this is how to write a thermochemical equation when we are in enthalpy, or when we are using the enthalpy change. So another example, let us test yourself. This is 5 points. Write the thermochemical equation for the reaction of N2 gas with O2 gas to make 2NO gas, which has an enthalpy change of 181 kilojoule. So I will give you 30 seconds to write the thermochemical equation for the reaction of N2 gas with O2 gas to make 2NO gas, which has an enthalpy change of 181 kilojoule. So how do we write the thermochemical equation for this? So the answer is N2 gas plus O2 gas yields 2NO gas. We write the delta H, that is equal to 181 kilojoule. That's it. So a chemical equation that includes an enthalpy change is called a thermochemical equation. Just like what we do before this, we write the thermochemical equation. A thermochemical equation is assumed to refer to the equation in molar quantities, which means it must be interpreted in terms of moles, not individual molecules. The delta H for a chemical reaction may be positive or negative. A chemical reaction that has positive is said to be endothermic, while a chemical reaction that has a negative delta H is said to be exothermic. Enthalpy change can be exothermic or endothermic. What does it mean if the delta H of a process is positive? So it means that the system in which the chemical reaction is occurring is gaining energy. The reactants has some energy, and the system increases its energy as it goes to products. Endothermic then implies that the system gains or absorbs energy. So when we say endothermic, the system gains or absorbs energy. If the enthalpy change of a reaction is negative, the system is losing energy. So the products have less energy than the reactants. And that is what we call exothermic, which implies that the system loses or gives off energy. So exo loses or gives off energy. So in an endothermic reaction, the energy of the system increases. So the energy of the system increases. Now, right, that is, it moves higher on the vertical scale of energy. So if we scale the energy in an endothermic reaction, the energy of the system is increasing. Now, in an exothermic reaction, the energy of the system decreases. This is the inverse of the endothermic reaction. So the energy of the system is decreasing. It moves lower on the vertical scale of the energy. So again, in an endothermic reaction, the energy of the system is increasing. While exothermic reaction, the energy is decreasing. For example, we have this equation, which is a thermochemical equation. 2CO gas plus O2 gas yields 2CO2 gas. The delta H is negative 565 kilojoule. So what do you think is the enthalpy change for this reaction? Is it exothermic or endothermic? How much energy is given off or absorbed? This reaction by definition, a chemical reaction that has a negative delta H is exothermic, meaning that this much energy, in this case is 565 kilojoule, is given off by the reaction. So this equation is this is an exothermic reaction because it has a negative sign, which indicates that the reaction is exothermic. And how much energy is given up or absorbed? It gives up negative 565 kilojoule. So, another example to test yourself. Consider this thermochemical equation. CO2 gas plus H2 gas yields CO gas plus H2O gas. And the delta H is 42 kilojoule. Is it exothermic or endothermic? You're right. It is endothermic. Why is it endothermic? Because we see a positive sign. If it is positive sign, we can also write like this, or just write the number. We don't see the negative sign here, so it is endothermic. And how much energy is given off or absorbed? Is it given off or absorbed? You're right. It is absorbed. So this means that we have 42 kilojoule energy that is being absorbed by the system. So the answer is endothermic, and 42 kilojoules are absorbed. So to summarize, the enthalpy is a thermodynamic quantity equivalent to the total heat content of a system denoted by H. And the enthalpy change, which is delta H, is the heat of a process when pressure is held constant. Delta H is equal to Q at constant pressure, where Q is equal to mc delta T, where m is the mass, C delta T is the specific temperature change. A chemical equation that includes an enthalpy change is called a thermochemical equation. Positive delta H defines or denotes that it gains energy, the system gains energy or absorbed energy, and that is endothermic. If delta H is negative, it loses energy or gives up, and it is called exothermic. So that's all. Thank you for watching. Have a safe and happy learning to all of you.